All right, so it is day 11 in pre-algebra, and today we are starting unit 3. We're talking about inequalities. Okay, now is that a word any of you have heard before? Or is this brand new? Brand new? Okay, might all be new to all of us. So an inequality is what we're going to be learning about today. But before we do that, I put in your do now introducing new symbols. Okay, so the first symbol I wanted to show you is this symbol right here. Now I drew some little teeth in the symbol to make it look like an alligator. And I'll tell you why here in a minute. But this symbol means greater than or bigger, and then the next symbol means less than or smaller. So we're going to use these symbols to compare two values or two numbers. So the activity that I have down here for you is involving just comparing some numbers. So for number 1, I have -3 is, and then I can say greater than, or I can say less than +10. So first, which number is bigger? 10 is bigger. So is -3 less than 10, or is -3 greater than 10? Less. It's less than 10. So here's where you're going to understand the teeth that I put in. Because 10 is the bigger number, -3 is less than 10. This is the less than symbol. I'm going to write in less than. This means less than. Now, where the teeth make sense is I like to think this is my alligator, and he is very hungry, and would he rather eat a tiny -3 or a great big 10? Well, he'd rather eat the 10 because he's hungry. So that's why his mouth is facing the bigger number. So that's how we can remember whatever side the big opening is on, that is the bigger part. The smaller part is where the point is. So -3 is less than 10. Awesome. Okay, do we have any questions about that? Or does that make sense? Make sense? Okay, so let's look at number 2. I forgot to white out that 27, so you already kind of have that answer there. We have 25 plus 2 is what then 28? 27? Yes, 25 plus 2 is 27. So we're really comparing 27 and 28. So is 27 greater than 28, or is it less than? Less than. So again, just like number 1, we write the less than symbol. And you can see the alligator's got his mouth open towards the bigger number. 27 is less than 28. Okay. Now number 3, we have two different values being compared. Before we can compare, we need to figure out what this number is for 3 times the quantity of 2 plus 3. So there's a couple different ways we could do this. I drew some arrows because you could do it by distribution, but we could also just use the order of operations. And since 2 plus 3 is in parentheses, we could do that first. But let's see, what do we want to try to simplify this first?
3 times.
3 times 2. Okay, so 3 times 2, and what is that? 6. Okay, so we did the 3 times 2. Now 3 times, yes, 3 times 3 is 9. Yes, so 6 plus 9 is 15. Okay, so now we know we're comparing 15 and 12. So is 15 less than 12 or is 15 greater than 12? Greater. 15 is a bigger number, so it is greater. So we draw the greater than symbol where the alligator's mouth is open towards the bigger number. He's gonna eat it. Okay. So we've got number 1, 2, and 3. Now, number 4, I have negative 36 and negative 2 times 50. Yeah, so what is negative 2 times 50? Almost 100. We're missing something. See it? Negative 100. We have a negative 2 times a positive 50. Remember, a negative times a positive is a negative. So negative 100 is what we are comparing. Now, comparing two negative numbers can be tricky. And we need to think about which one is actually smaller, which one's actually bigger. So negative 36 and negative 100, which one has a bigger value? Positive 100 would have a bigger value.
Yeah.
But this is negative.
And a negative is a positive.
But now we have just negative 100 and negative 36. We're just comparing those two. So how about we put them on a number line? And let's think about it. So here's 0.
Yeah.
Okay. My positive numbers are this way. My negative are this way. And we know that positive numbers, we go like, I'll put by tens. 10, 20, 30, 40, 50, dot, 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 dot. And it keeps going. When we get to negative numbers, remember they work backwards. So, negative 10, negative 20, negative 30, skip a few, negative 100. We keep going. So, when we're looking at a number line, numbers that are more towards the right, towards this positive, are bigger. Numbers that are more towards the left are smaller. So 36, if it was positive, is less than positive 100. But what about negative 100 and negative 36? Here's negative 100. Here's about negative 36. Remember, if it's towards the right, it's bigger. Towards the left is smaller. So which one is the bigger value? Negative 36 is bigger, believe it or not.
Because it moves the lost value.
Yeah. Think of it like this too. Would you rather have negative $36 in your bank account, or would you rather have negative $100? Right, because negative 36 means you actually have a little more money, because negative 100 you owe a lot more. So negative 36 is greater than negative 100. Now, does that make sense to everybody? Okay. Negatives are tricky.
Yes, they are.
So, that is our do now. And then I just gave you a little sneak peek of what we're doing today. We are going to talk about what an inequality is. We've already talked about less than versus greater than, so we can move on from that. And then I'm going to show you how to solve an inequality. Okay. And if there's time, we might graph an inequality, but we'll see. We'll see how long it takes. So I'm going to move this, and we are going to start some notes. So this is pre-algebra. And we are starting Unit 3. And we're going to write inequalities. Okay, and these will be our day 11 notes. This is page 1. So, an inequality. We're going to answer that question. What is an inequality? I'm going to give you an example of an inequality. I'm going to write the word again. Inequality. An inequality is basically a number sentence. I call it a number sentence. It's like a statement about numbers, not using words, just using numbers. And it's used to compare. Compare meaning now we're not saying this is equal to that. Now we're saying this is less than that. This is greater than that. We're not saying equal anymore. So,
And meaning subtraction, like take away. Equality.
Inequality. So in, we want to think of that as like not.
Yeah.
Unequal, not equal. So we're talking about things that are not equal. It's things that are greater than or less than each other. So I'm going to write, let's see, inequality used to compare unequal. So not equal values. So that's our inequality definition. And then we want to also write a little note about less than versus greater than, just to have it on our paper. So we have, I'll write in red, less than, and less than, if we start from left to right, the less than has the smaller, the closed end coming first, and then it gets bigger as it opens. That's less than. Greater than if we're going left to right, you see the big opening first, and then it gets smaller. So less than, greater than. Those are our symbols for now. Okay. So now we're going to write some examples. Under here, I'm going to write solving inequalities. And the first example I will give you is n plus 3 is greater than 5. N plus 3 is greater than 5. Now, this is going to be very similar to Unit 2. In Unit 2, we learned how to solve equations. Now we're solving inequalities. And the beautiful thing about inequalities is you solve them just like equations. You solve them the exact same way. We're still using inverse operations. And I'll write that over to the side just as a reminder. Inverse operations. And that is where we have addition. That is the opposite of subtraction. And then our multiplication and division. Okay. So that's just a side note as a reminder. So looking back at this n plus 3 is greater than 5. Let's pretend that greater than is an equal sign. If you were trying to solve for n, what would you do here?
So let's pretend what?
Let's pretend this greater than symbol is just an equal sign.
Okay.
If it was an equal sign, how would you solve this? Subtract 3 from both sides. Okay, so let's do that. Minus 3. Minus 3. Okay. And what would happen next?
I'm sorry, subtract.
Yes, so what happens to my 3's?
Oh, you
Cross out the 3's.
Yes.
Okay, so we've got that.
We subtract.
I'll bring down my n. Now 5 minus 3, what is that?
2.
2. Now, instead of bringing down an equal sign, we need to be careful that we bring down the same symbol.
Okay.
That greater than. So I'm going to write in between my n and my 2, greater than.
So we're looking at the symbol as the equal sign.
Yes, exactly.
Okay, so okay.
Exactly. But now it's a slightly different thing that we just solved, because normally we would say, oh, n equals 2. That's what n is. It's 2. But what we just solved for is that n can be any number that is bigger than 2. Because we need to find what numbers can I plug in to make this true. How can I have a number that's bigger than 5? So, for example, let's try an example for n. If n is greater than 2, what's a random number bigger than 2? 4. Okay, so let's try 4. So what if I replaced n with 4?
You want to rewrite the whole problem?
Yeah, I'm going to write this off to the side with a sticky note. This is more so me just showing you what it means. You don't have to add it to your notes, but that's why I'm doing it on a sticky. So let's try 4. Okay. So 4 instead of n plus 3 is greater than 5. Okay, so what would I do next?
Okay, you would, that is the time, right?
So I only have the parentheses here to show that this used to be n and I replaced it with 4.
Oh, okay, so you want to do the same thing, 3 into 3?
So we're not solving for n anymore. Now I'm just trying to see, is this true? Is 4 plus 3 bigger than 5?
Yes.
What is 4 plus
It's
3?
7.
It's 7. That's what we needed. 7 is greater than 5. And now we ask her, is this true?
Yes.
It is true. Yes. So we know that's going to work. Now, what if we tried to use 2 for n? Could we? Yeah, could 2 be a value for n?
What do you mean by that, first of all?
We can try, like, can I use the number 2?
It's gonna be greater than.
Let's see. Yeah, I think you're right. Let's try this. Let's see if n really does have to be bigger than 2. So what if we use 2?
And the
So if I replace n with 2 plus 3 is greater than 5. Okay.
Yes.
So is 2 plus 3 bigger than 5?
No, they're the same, they're equal.
Yes. No, they're equal. So 5 greater than 5? No, it's
No.
not. And that's why we can't say n is equal to 2. We say n has to be a number that's bigger than 2. And that's what will make this true. If I try smaller than 2, it's not going to work. 1 plus 3 is 4. 4 is not bigger than 5. 0 plus 3 is 3. 3 is not bigger than 5. Yeah, has to be bigger than 2. So, we've solved our first inequality. It's not too bad. Now, let's try another one. How about 5n is less than 15?
Okay, basically, wait a minute. 5 times 5.
Yeah, remember 5n, what does that mean? What operation?
Multiply.
Yes, multiply. This is 5 times n. So, we want to do the opposite. Divide. Perfect. So, let's try that. I'm going to divide by 5 on both sides. Yes. And what happens to my 5s? Cross them out, they cancel. Now we'll bring down the n. What should I do next? And what will that give me? 3. And I just need to bring down my less than symbol. So n is less than 3. Yes, yes. N is less than 3. So this means this original inequality is true if I use a number that is smaller than 3 for n. 5 times 3 is 15. 15 is not less than 15. We have to use a smaller number than that. Like 5 times 2, that would be 10. 10 is less than 15. That's true. That would work. So we just found out that I can use any number for n as long as it's smaller or less than 3. Okay. So inequalities are not too bad. The only difference is that we don't have an equal sign. We have a less than or a greater than sign. So that's the only real difference for now. Let's see. What if I gave you another problem like this? 3n plus 4 is less than 10. see if you can do that one on your own. This is a two-step inequality. So don't forget the order that we're getting rid of numbers in. Just like equations. I'm going to pause this and let you guys try this for a minute. Alright, so where do I start with this one? The 4, what do I do? Minus or subtract, good. Subtract 4.
Subtract 4 from 10, we have 6.
Yes.
Then you bring all of that down to 6. Then we bring down the minus sign.
Do I bring a minus sign
No, not
down?
yet. I'm sorry.
What did I forget to do with my 4s?
You forgot to cross them out.
Cross them out.
Then you bring down the 3 in.
Yes, 3 in.
Okay.
And what else do I bring down?
Bring down the less than.
Yes, good, less than. Okay.
Okay, now we're going to divide.
Yes,
3
ma'am.
and 3. And we're going to. We have n.
We do have n.
It's nothing, yeah, because it counts as 1. But actually, we don't do that. So it's actually nothing. The n minus the 6.
N. Okay, but what did I forget to do over here?
Oh, divide.
Divide by 3. We got to do it on both
Yeah,
sides.
right.
Yes. Okay. Now we do have n by itself, but what else?
You have to divide 3 into 2. And 3
Yeah.
divided by 6 is 2.
Yes, or 6 divided by 3. We say that bigger number first.
Okay.
6 divided by 3 gives us 2. And
That's it.
n is less than 2. And that's your answer. Very nice. And that's it. You solved it. Okay, how about this one?
Good luck, somebody.
How would I begin?
Would you begin with the minus signs?
With my minus signs.
With the 4 and the 7.
With the 4? Yes. What would I do with the 4? Add 4. Good. I'm going to add 4. And where else? Under the minus 7 or the negative 7. So, I've got, what do I do here now?
You have to do some, when you cross out the
4s are
first
gone.
of all,
Mm-hmm.
and then you add the 7 and the 4.
Now, is it 7?
The minus
Negative 7
and
plus
minus
4. What is that going to give me? Negative 3. If I have negative 7 and I add 4, I'm not crossing 0 yet. I'm still in the negatives. So, we're really subtracting here. 7 minus 4 is 3, and 7 is the bigger number, so it's got that negative. So, negative 3. Uh-huh. There we go. Now what? Bring the n over 2 down. Good. Bring down the greater than sign. Okay. Good. Now we have n divided by 2, so we will take it times 2 on both sides. And yes, those 2's cancel. I'll bring down my n, my greater than sign, and you are correct, negative 6. So n is greater than negative 6. There we go. Okay. You guys got that?
So basically, all we did in these problems is you added the less than and the lesser signs and the greater signs.
Yep, that's
That's all you
it.
did.
That's the only
Just added
difference.
it to 'em.
Everything is exactly the same as solving equations. That's it. Okay. So, if we feel okay about that, I do want to show you the graphing, because as scary as it sounds, it's not, I promise. I think you'll actually like it. A lot of my students enjoy it. So, Can I move this? Anyone still need it?
You said, what are you going to do?
I'm going to show you how to graph these. Now, we're not doing like a full graph. It's actually on a number line, so it's not as insane as it might look, or sound. It won't look crazy. So I'm going to rip this out, and I'm going to title my next page Pre-Algebra, and we're still in Unit 3, and it's day 11 notes continued. And this is our second page, page 2. Okay, so we are going to now title this page Graphing Inequalities. So, graph graphing inequalities. Okay, so we are going to start with an example like this. Let's say, I'm going to switch us to a different variable. Let's use x this time. I'm going to say x is greater than 4. So this is already solved. We already know that x can only be a number that is bigger than 4. So here's how we graph that. First, I'm going to get a ruler. And I am going to, right beside this, draw a line, and I'm going to make it, if you're trying to copy mine, I'm going to make it about 10 centimeters. Just like that. And on each end of our line, we're making basically a number line. We want to put arrows. And somewhere in the middle of this line, we're going to put a little, what I call a tick mark. Just a little dash, a tick mark right in the middle. Then I like to also put a plus on the right side and a minus on the left, just to help us remember. And once we have that, underneath this inequality I've given you, I'm going to write out what the symbol means so that when we see it in our notes, it's easier to remember. I'm going to write x is greater than . X is greater than 4. So here's how I would graph this. I want my number line or my graph to show every possible number that x could be. So to do that, on my tick mark, I'm going to write the number 4. That's the first thing. We just write the number. Then we are going to, on this tick mark, we're going to circle it. And we are going to leave that circle open. Do not shade it in. And because x has to be a number that is bigger than 4, I'm going to color in all of the numbers that x could be. So to the right is all the numbers that are bigger than 4. So we just color it in like that. And the reason we don't color 4 is because we're saying x has to be greater than 4. So it can't be 4, but it can be every number that's bigger. So that's why we leave 4 open. We don't shade it in. Everything that is shaded could be x. And you've graphed an inequality. That's it. Not too bad.
Everything that's shaded can be x.
Yes. So this represents everything over here. Like if we were to add more numbers to this number line, this could be 5, 6, 7, and it goes on forever until infinity. So this graph does represent every single number that x could be. Because nobody wants to write all those numbers, so we just draw a picture, and it shows it. So now let's try making a graph for less than. Let's say now x is less than 10. And I will go ahead and do the same thing I did above. I'm going to make a line. And arrows on the ends. And a tick mark in the middle. My minus and my plus. And then I'm going to write out the word version of this. X is less than 10. Okay. So, based off of what we did for x is greater than 4, remember the first thing we did is we wrote the 4, we circled the tick mark, and then we shaded. Those 3 steps. So, what do you think we would do for x is less than 10? Put the 10, circle it. Now, which way do you think we'll shade?
The minus.
Towards the minus, to the left. Because now we need to shade in all the numbers smaller than 10. And that's it. You've graphed it. So, now we know how to do that. Now we know. All right. So we have a greater than graph, we have a less than graph, and I also have a little trick for remembering which direction to shade. So if we're looking, for example, at greater than, here's my greater than symbol. Sometimes it helps to write that symbol over here next to your graph. There's greater than. And it's really easy to mix up because you might see, oh, well, my opening is this way, so I'm going to shade this way. Don't do that. We want to think of our symbol as being an arrow. See that? And the arrow points which way you should shade. I like doing it like that. Same with less than. If I draw my less than symbol right here, I just turn it into an arrow, and the arrow tells me which way to shade. So those are my little tricks. That's what I think helps. Okay. So, let me pause this, and I have a little worksheet that we're going to look at. All right, I'm going to have you try this one on your own. I'm going to have you solve an inequality just like we did on our last page of notes. And then once you've solved it, I want you to graph it. So, solve and graph. So let's do 4x plus 1 is greater than 17. So you're going to solve this, and once you have your answer for x, I want you to make the graph right next to it. Okay, so I am going to pause our video, and I'm going to come around and actually not I'm going to come around. I'm going to have you, if you finish this, raise your hand and I will come check it, and then we'll go from there. So I'm going to pause that again.